Hello and welcome to the Section 11.3 application walkthrough. In this section we are looking at graphing radical equations. So this is some complex stuff here. I'm just going to help you out by getting started on these table of values for the first two problems. Remember to start with your smart number, or really all your smart numbers. And just to give you a hint, I'm going to go ahead and start off with -2 here, because that would make that inside 0. Okay, and you'll have to pick your smart numbers from there. But looking at this, so -2 plus 2 is 0, square root of 0 is 0, -2 times 0 is 0, and we're just going to get a plus 5 over there for the y coordinate. Okay. In the next one, I would center this one around what makes this 0. It's going to be -5. All right. So same type of deal. All that stuff is going to go away. It's going to go to 0. I'm going to be left with -5 as my other coordinate. So it's going to start down here and probably go up this way somehow. Okay, so I'm going to let you finish that. Just remember, pick your smart numbers, and those are just numbers that are going to give you whole number answers instead of decimals, or really what become irrational numbers. We don't really like graphing those. We like whole number, we like integer answers. So it just makes life a lot easier. So go ahead and figure out what those are and continue on. In number 3, it's more of an interesting problem, I think, because when you look at it, it's it's what people actually do, and it's some people can even get a job out of it if they're good enough at it. So here we're investigating accidents, an accident reconstructionist. So that's the person who's responsible for finding out how fast the cars were going before an accident. The way they figure that out is they use the model below, where S is the speed of the cars in miles per hour, or of one car. D is the length of the tire's skid marks in feet, and F is the coefficient of friction for the road. Usually that's pretty, I'm not going to say that it's the same all the time, but for most driving surfaces, it's pretty close to the same. So for part A here, it says, in an accident, a car makes skid marks 74 feet long. The coefficient of friction is 0.5, and the witness says that the car was driving faster than 45 miles per hour at the time of the accident. So can the witness's statement be correct? Explain. Really what I want you to do is solve for S. All right, you have the length of the skid marks, so that's your D, and this right here is your F. Okay, plug those in, take the square root, see what you get. Okay, not too bad. And so then, that's solving for S is going to tell you what the speed is, and then you can judge whether the witness's statement is correct or not. Okay, so based on the verbiage of part B here, that kind of tells you that the person is wrong, that the witness is wrong. But so it says, how long would the skid marks have to be in order to know that the car was traveling faster than 45 miles per hour? The way we're going to look at this is, let's say the car was traveling 45 miles per hour. So that's the speed. Okay, we know that we have 30d times the coefficient of friction was still 0.5. Okay, really what that means is that 0.5 times 30 is 15. So we have 15d there. Now we haven't really talked about how to solve these problems yet, and that's why I'm going to help you out right now. In order to get rid of a square root symbol on one side of solving an equation, I need to square both sides. Because the square root of anything squared is just whatever's under the square root sign. So we're going to have to do a quick little math here. 45 squared is 2025. So 2025. And that's going to equal 15d. Okay, so divide by 15. And when I get that, that says that 135 equals d. Okay, so that means that if the car was going 45 miles an hour, the skid marks would have been 135 feet long. Okay, but to know that it was traveling faster than 45 miles an hour, I'm just going to say that skid marks would have to be more than or longer than 135 feet. Okay, that would tell us that the car was traveling faster than 45 miles an hour. So really we could have set this up as an inequality, but I didn't want to think that much, about solving inequalities. I just looked at it as an equation and used my logic to progress it to an inequality situation. So kind of giving you the answer a little bit to part A there, but I still need to see that work, figuring out actually how fast the car was going, okay, and then explaining that the witness could not be right, okay. But after that, you guys are good to go, and that'll be chapter 11 or unit 11 in the book, and you guys are doing great. Good luck on that mastery challenge and the unit test coming up. Let me know if you have any questions. I'm here to help. See you later.